Hey guys, this is Mrs. Harbin and this is Algebra 2. Today we are going to take a look at Algebra 2, Chapter 1, Section 1.2, Real Number Operations. Now, this should be a review for you guys, but if, it's been a few years and you've forgotten how to do some of these things, hopefully this will bring it back. If after watching this video and after going through class, you're still struggling with this, please do see me so we can get this taken care of and help you relearn or maybe learn for the first time how to do these things. So our objective for today is that you, the student, will find the absolute value of a real number and evaluate numerical expressions using the order of operations. We're also going to review how to add and subtract integers with same signs and different signs as a quick review. So let's take a look at some basic arithmetic operations. We have 4 operations in math, and you can see here this is vocabulary, so make sure in your math journal you're writing this maybe in the vocabulary section of your notes here. So our first arithmetic operation is addition, and in addition we have digits that we're adding. They could be rational numbers, they could be integers, whole numbers, we could add anything, but we call these digits or these numbers add-ins. And when we add them together, our answer, or what happens when we combine them, is your sum. Our second operation is subtraction, and in subtraction you have a minuend, which is the bigger number typically, the subtrahend, what you're taking away, what you are subtracting, and your answer is called the difference. In multiplication, which is our third operation, the numbers that we're multiplying are called factors, and factor times factor equals product. Our fourth operation, basic operation, is division, and division, you start with a dividend, and divisor is what you're dividing into that dividend, and then your answer is the quotient. Our final operation that's listed here is exponentiation. And exponentiation is just a form of multiplication. It's actually repeated multiplication, but we have some special terminology here. We have a base being raised to an exponent. So let's go through quickly and put some numbers here because numbers often make more sense than words. So in addition, if one of our add-ins is 2 and our other add-in is 3, then our sum is 5. In subtraction, if our minuend is 10, and our subtrahend is 7, then our difference is 3. And if you were to put those on a number line, you would see that the number of units or spaces between 7 and 10 on the number line, the difference between those two numbers, excuse me, is 3. In multiplication, we might have a factor of 3 and a factor of 2, and our product in that case, 3 times 2 is 6. And in division, our dividend might be 12, and we're dividing that into groups of 2. We're dividing it into 2 groups, and our quotient would be 6. And exponentiation, again, we have a base and an exponent, so our base might be 2, and our exponent might be 3. This just is repeated multiplication. It means 2 times itself 3 times, so 2 times 2 times 2, in this case, 8. Remember that addition and subtraction are inverse operations. They undo each other. If I add 2 to something, the way that I undo that is to take 2 away. And multiplication and division are also inverse operations. If I increase something by a factor of 2, if I double it, multiply it by 2, the way that I undo that is to divide it by 2 or cut it in half. So these are inverse operations. You haven't learned yet about the inverse of exponents, although you definitely will get to that this year. So let's add another term to our vocabulary here, the absolute value. The absolute value of a number, which we represent with these straight bars, x representing any number, is the number of units or the distance between 0 and the numbers graph on a number line. We can also call 0 the origin. All right, so if we're thinking about a number line here, this is not going to be very straight, but here's my number line, and here is 0. It's the distance between 0 and the numbers graph. The numbers graph is where it's located on the number line. So let's make some marks here and put a 3 right here. And the distance between 0 and the numbers graph on this number line is 3. So the absolute value of 3 is 3. Conversely, if we go to the opposite number, the opposite of 3 is negative 3. We'll graph that number. And if you look at the distance between -3 and 0, the absolute value of -3 is also 3. Both of these are 3 units away from the origin or from the 0. In fact, a number like 10 and its opposite number, -10, always have the same absolute value. So 10 and -10 both have the absolute value of 10. They're both 10 units away from 0. Absolute value is always positive because when we measure distance is positive. So the absolute value of -10, how many units away from 0 is it? 10. So absolute value of a number is always positive, or it can be 0. The absolute value of 0 is 0. It's 0 units away from itself. So add that to your definitions as well. All right, let's talk about adding very quickly, about adding add-ins that may or may not have the same sign. We saw earlier that the numbers being added are called the add-ins, and the answer to an addition problem is called the sum. So we've got some steps here, or some processes that we can remember to help us when adding. So you may want to put these in the steps section of your journal. There are 2 steps when we have the same sign on the add-ins. So if we're adding, if we have 2 add-ins and they are both positive or they're both negative, they have the same signs. First, we add the absolute values of the add-ins. That's essentially just the digit without regard for the sign. Then we give the sum the sign of the 2 add-ins. So let's write those steps down and then take a look at some examples. Add the absolute value, give the sum the sign of the 2 add-ins. So here's your first example, 3 and 2. So without regard for whether these are positive or negative, we know that the absolute value of 3 is 3 and the absolute value of 2 is 2. Both of these are positive. So let's add those 2 digits, 3 and 2 is 5. And we give our answer the sum, or the sign of the 2 add-ins. Both of these add-ins are positive numbers, so our answer is a positive 5. Here we have -1 plus -3. Again, we're just going to add the 2 digits, 1 plus 3. Because the signs are the same, we cannot worry about those for just a second. Well, 1 plus 3 is 4, but then we have to give our final answer, our sum, the same sign as the 2 add-ins. Both of these were negative, so our answer is also going to be negative, -4. If you were to put these on a number line and try to visualize it, the first number is where you start. So let's start at 0 here. And we're going to start at 3. And then plus 2 means we move to the right 2. 1, 2. On the number line, that puts us at 5. Right? On this number line here, we're going to start at -1. And this at first tells me to move right, but then there's a negative sign. That switches directions, so we're actually going to move left. 1, 2, 3. And when I go back 3, I'm now at -4. So if you wanted to visualize that on the number line, that's what it looks like. But using our signs, when our add-ins have the same sign, add the digits, or the absolute value of the digits, and give the sum, or the answer, the same sign as your 2 add-ins. Now let's take a look at what happens when your add-ins have different signs. So first, you're going to subtract the smaller absolute value from the larger absolute value, or subtract the smaller digit from the larger digit, without regard for the signs. Give the difference, which is your answer, the sign of the add-in with the larger absolute value. Let's take a look at an example here. We've got maybe, I'll write my example to the side here. If we have 5 plus -3, subtract the smaller from the larger. 5 and 3, 3 is smaller, so I'm going to subtract 5 minus 3, and that is 2. Give the difference, your answer, the sign of the add-in with the larger absolute value. Well, 5 had the larger absolute value. It was positive, so my answer was positive. All right, let's try another one. What if we had -3 plus 2? Again, subtract the smaller absolute value from the larger absolute value. The absolute value of this is 3, and the absolute value of this is 2, so I'm going to subtract 2 from 3. 3 minus 2. You just subtract the digits without regard to the sign. Okay, that means my difference is 1, but I need to go to step 2. Give the difference the sign of the addend with the larger absolute value. Well, this is the one that had the larger absolute value, and it was negative, so my difference is also negative. Again, if we try to visualize that on a number line here, let's start with 0. Here's negative 3, 1, 2, 3. So that's where we're going to start. And then plus 2 means we go to the right 2. 1, 2. And here we are at negative 1, right where we said we would be. Another way that you might want to think of it is a little bit like this. Numbers represent soldiers at war. You have your red soldiers, which are your negative numbers, and your blue soldiers, which are your positive numbers. So here in this problem, we have 3 positive soldiers, blue, and 2 negative, 2 red. If we were to line those up, we've got our 3 red ones here, and our 3 blue ones, and our 2 red ones. These will cancel each other out. And what you're left with is 1 left over. That blue is positive, so our answer is 1 positive, or positive 1. So there are lots of ways that you can add and subtract addends that have same or different signs. Whether you use the rules or the steps that I just gave you, or try to visualize it or write it on a number line, or even match them up in pairs and cancel them out. Obviously, this is easy to do with smaller numbers, and larger numbers you don't want to draw 47 little circles and cancel them out. So the rules will be helpful to you in those cases. All right, let's take a quick minute to review the order of operations. You see here we have PEMDAS, PEMDAS. That tells us the order that we need to simplify problems with. We're actually going to change this to a G and talk about that in just a second. This is going to be called GEMDAS. And that G is going to stand for grouping symbols. Parentheses are only one type of grouping symbol. You might also see brackets, square brackets. You might see braces. I'm not very good at drawing those. That's also a grouping symbol. You might see absolute value bars. Those are grouping symbols. You might also see a radical sign, which can function as a grouping symbol as well. So anything in the grouping symbol needs to be simplified first. And after that, we would then do any exponents. Third step is to do multiplication and division at the exact same time, moving from left to right. And last but not least, we have addition and subtraction at the exact same time, moving from left to right. So let's go ahead and take a look at a problem and practice our order of operations. So we have 2 plus 4 times 3. According to our order of operations here, we need to do anything in a grouping symbol. Well, we don't have any. Then exponents, don't have any of those. Next, we're going to do multiplication and division from left to right. And as I move from left to right here, I see one multiplication or division problem, 4 times 3. So I'm going to put a little bracket around that so I know that this is what I'm doing. And then I'm going to rewrite my problem down below. However, instead of 4 times 3, I'm going to simplify that and write that as 2 plus, instead of 4 times 3, 2 plus 12. I don't have any more multiplication and division, so now I do addition and subtraction left to right. And as I go from left to right, I have one addition and or subtraction problem, 2 plus 12. So I'm going to put a bracket around it since that's what I'm working with. And then I simplify that down below. 2 plus 12 equals 14. All right, let's try another one here. I am running out of time here, so this may be the last one that we do, GEMDAS. And here we go. Grouping symbols I need to simplify first, which means I need to simplify this, and I need to simplify this. So I'm going to put brackets around it and bring it down a step. So I have negative 2 squared plus 1 minus 3, which is negative 2 to the 4th, minus 2 times 4 minus 3, which is 1. Then I do my exponents. Now, I need to tell you something very quickly about this exponent right here, but I'm about to run out of time. So that will be in part 2 of this video. Hang tight for part 2.